Good day, my dear grade 10 students. In this lecture video, we are going to discuss about the lesson 1 and lesson 2 for the module number 1. Now let us start with lesson 1, which is entitled Finding the Term of a Sequence. So before we're going to discuss about finding the terms of a sequence, let us have first some activity which will measure your previous knowledge on the lesson of evaluating algebraic expression. So we have the directions. Evaluate the following expressions. Choose the number inside the box that corresponds to your answer. So we have number 1, 8 plus 9 divided by 3. Now you have to recall that using the operation in mathematics, the addition, subtraction, multiplication, and division, we need to follow some rules, which is the PEMDAS rule. Okay, we have the PEMDAS. I'm expecting that you already know the meaning of PEMDAS. P stands for the parenthesis, E stands for exponent, M multiplication, D division, A addition, and S stands for subtraction. Now for example number 1, we have 8 plus 9 divided by 3. So what we're going to do first is finding the quotient of 9 divided by 3, because this operation division is comes first before the addition sign. So we are going to have 8 plus 9 divided by 3, which is equal to 3, and 8 plus 3 is equal to 11. So the answer of example number 1 is 11, that is found in the box. For example number 2, again the same process. We're going to use the PEMDAS rule. So since we have a parenthesis, and inside the parenthesis there is 8 plus 2, so we're going to make it first. So therefore we have 12 times inside the parenthesis 8 plus 2, which is equal to 10 minus 7. So we have 12 times 10 minus 7, or 7. So 12 times 10, that is equal to 120 minus 7. The final answer is 113. So it is found in the box. Example number 3. 8 minus 2 squared plus 3. So as you have seen, there is an exponent above the 2. So what we're going to do is to make the solution first with 2 squared. So we have 8 minus 2 squared, which is equal to 4 plus 3. So the final answer for example number 3 is 8 minus 2 minus 4 rather is equal to 4 plus 3, which is equal to 7. It can be found also in the box given in under or below the examples. So for example number 3, 3n minus 1 when n is equal to 3. So what is 3n minus 1 when n is equal to 3? So itong buhaton is to substitute the value of n, which is 3, to this given equation. So we have 3 and substitute with 3 minus 1. So that is equal to 3 times 3, 9 minus 1 equals 8. So it can also be found in the box. And lastly, for example number 5, what is x plus 3y when x is equal to 1 and y is equal to negative 2? So we're going to substitute the values of x and y here in our equation, x plus 3y. So if x is equal to 1 plus 3 and y is equal to negative 2. Na-substitute na, so therefore we're going to find the product as well as the sum of the given integers. So we have 1 plus, what is 3 times negative 2? That is equal to negative 6. And 1 minus 6 is equal to negative 5, which can be also found in the box given below. Okay, for our activity number 2, so study the figures below. So in the figure number 1, or the first figure, you can find, or you can see a triangle. So 1, 2, 3, 4. There are 5 shapes, or what we call a polygon. So the figure number 1 is a triangle having 3 sides. The second figure is a square, closed shape polygon that has 4 sides. The third one is also a polygon having 5 sides, and this is what we call a pentagon. The fourth one is a polygon having 6 sides, or what we call the hexagon. And the fifth one is a 6-sided polygon, and it is called a hexagon. The fourth one is what we call heptagon. A pentagon rather. So having a polygon having 5 sides is what we call a pentagon, and a polygon having 3 sides is called a hexagon. Now in question number A, letter A, do the figure show a pattern? Describe it. So what will be the 6th figure following the first 5 figure in the example number 1? The first one having 3 sides, second 4 sides, third having 5 sides, fourth having a 5 sides or 6 sides, and the fifth one having a 1, 2, 3, 4, 5, 6, 7 7 sides. So it is a heptagon. Now what will be the 6th figure? So we have an octagon. Okay, an octagon having a figure of 8 sides. 8 sides. So I will not draw it, but I know you already know what is the shape of octagon. A closed figure or a polygon having 8 sides. So let us proceed to example number 2. Mr. Santos is planning to buy a laptop for his incoming grade 10 student. To prepare for this, he is thinking of saving 1,700 pesos every month starting next month. He has already saved 5,000 pesos for this purpose. So the question is, how much will Mr. Santos have saved after 2 months. After 3 months, 4 months, after 5 months, 6 months, after 7 months. Summarize your answer using the table below. So we have the table. Okay? So nakasave na si Mr. Santos og 5,000 pesos. So the first month he has already saved 5,000 pesos. Now he will start saving money for the laptop of his son or daughter. Maybe next month siya mag-start og 1,500 pesos. So the following month mag-add og from 5,000 maka-save na pud siya og 1,700. So therefore the next month around he will have a savings of 6,700. For the third month, another 1,700 added, so we have 8,400. For the fourth month, another 1,700 for his savings, so 8,700. He will have 1,7,001. So he will have 10,100 for the fourth month of his savings. For the fifth month, another 1,700. He will have a savings of 11,800. The sixth month, another 1,700 pesos again. So his savings will become 13,500. And for seventh month, having additional of 1,700, his total savings for the seventh month is 15,200. So that will be the savings of Mr. Santos if we're going to save his money for a span of 7 months. Now, those activities, those set of numbers and figures in the previous activities that we have already discussed are called a sequence. And each sequence or each number of a sequence is called a term. So a sequence is simply a set of numbers in a particular order, or it is a set of numbers which follow a pattern. So ang sequence naga-follow siya og pattern. A sequence may be generated from shapes, patterns, and rule. So we have most basic example of that is accounting numbers. So we have 1, 2, 3, 4, and 5, ... So, or we have 1, 11, 21, 31, 41, and 51. That is example of a sequence. So okay, so there are two types of a sequence. So the first one is a finite sequence. So we have an example below, the sequence A and sequence B. So in sequence A, we have 10, 12, 14, 16, and 18. While the sequence B is R 10, 12, 14, 16, 18, so on and so forth. So the sequence A is a finite sequence because it has a last term, which is 18. So again, the sequence A is a finite sequence because it has a last term. So nasa'y last term. While in sequence B is an infinite sequence because it has no last terms, which means it continuously infinitely. It means it continues is infinitely. So have you seen these three dots? It signifies as ellipses. So meaning infinite ang iyang terms. So walay kahumanan ang iyang terms. So finite and infinite sequence. Okay, let us proceed. So we're going to discuss about writing the first few terms of a sequence. So a sequence is usually given by stating the general rule or its nth term. Therefore, we can find its next few terms. So we have example number 1. Write the first 5 terms of the sequence whose nth term is given by a sub n equals 2n plus 1. Okay, so let us go back to our example for the sequence. So this is the example of a sequence 1, 11, 21, 31, 41, and 51, which is the first term. The 1 is what we call the first term. First term ang tawag ana. Kay its values of a sequence is what we call a terms. So the 1 is the first term. The next is the second term. 21 is the third term. 31 as the fourth term. 41 as fifth term, and 51 as the sixth term. Now these terms can be also written as a sub 1 can be read as a sub 1. The first term can be read as a sub 1 or a na ay 1 sa baba. A sub 2 for the second term can be read as a sub 2 or the second term. A sub 3 can be read as a sub 3, which is the third term of the sequence. A sub 4 for the fourth term, and a sub 5 for the fifth term, a sub 6 for the sixth term, and so on and so forth. Okay, so let's go back to our example number 1. Write the first 5 terms of the sequence whose nth term is given by a sub n equals 2n plus 1. So ang gipangita nato diri ang first 5 terms daw sa sequence. Okay? So let n is equal to a number of terms of the sequence. Number of terms. So 5 man atong gipangita nga term. So kada n nato dira substituta nato og numbers from 1 to 5. So we have a sub 1, which is the first term, kay ang n nato is 1. Taman ta sa a sub 2, a sub 3, a sub 4, and a sub 5, since ang gipangita is or the 5 terms of the sequence. If we have a sub 1, our n is equal to 1. Using this given formula, we have 2 times 1, since 1 is our n, plus 1, which is equal to 2 times 1, 2, plus 1 equals 3. So our first term is equal to 3. The second term, using this formula given, so we are going to substitute n with 2. So therefore we have 2, n is equal to 2, which is the second term, plus 1 all over, or equal to 5. The same process in finding the third term, or the a sub 3. Substitute n with 3 plus 1 is equal to 7. A sub 4 is equal to 2 times n, which is 4, plus 1, that is equal to 9. And the fifth term is equal to, or the a sub 5 is equal to 2. Our n is equal to 5, plus 1 is equal to 11. So we have the first 5 terms of the sequence, which are the 3, 5, 7, 9, and 11. So these are the first 5 terms of the sequence. So example number 3. So what is the 10th term of the sequence defined by the formula a sub n equals n squared plus n minus 1? So ang gipangita nato dire is the nth term of the sequence, nga ang formula is a sub n equals n squared plus n minus 1. So in finding the 10th term, we are going to substitute n with 10. So therefore we have a sub 10, since atong gipangita is the 10th term of the sequence, we have a sub 10. Again, substituting n with 10. So we have 10 squared plus n is equal to 10 again, minus 1. So a sub 10, or the 10th term, is equal to, what is 10 squared? That is equal to 100 plus 10 minus 1. So therefore, the 10th term of the sequence, having the formula of n squared plus n minus 1, is equal to 109. 100 plus 10, 110 minus 9 is equal to 109. So this is the 10th term of the sequence. Okay, so that's all for the lesson 1 of module number 1, which is finding the terms of a sequence. Hope that you have understood our discussion, our lecture video. So we are going to proceed for the lesson number 2 of module number 1.